Let me start with a statement that will sound outrageous to many defense analysts. The most expensive American fighter jets ever built may already be strategically obsolete, not because they cannot fly faster or because their stealth technology suddenly stopped working, but because the battlefield itself has quietly changed, and China understood that change earlier than almost anyone in Washington. So let me ask you a simple question. What happens when a $25 million fighter jet meets a swarm of autonomous drones that cost less than $30,000 each? Most people think the answer is obvious. The jet wins. After all, that's how warfare has worked for decades. But here's what mainstream defense conversations get wrong. They are still imagining yesterday's battlefield. Here's what nobody tells you. China is not trying to beat American air-power jet for jet. That would be absurdly expensive. Instead, Beijing is redesigning the entire equation of air warfare. If you want to understand how this works, you have to look at three systems China has been quietly building for more than a decade. Three forces that together could redefine military power in the 21st century. System number one is mass production at a scale no other country can match. System number two is networked intelligence, where thousands of machines share data in real time. And system number three is economic warfare through cost asymmetry. Stay with me because what comes next changes everything. Let's start with the first system, manufacturing scale. And the numbers here are not vague estimates. They are staggering. In 2023 alone, China produced more than 3.4 million commercial and industrial drones. That's according to industry export filings. The United States produced fewer than 320,000. Let me show you what this actually means. Manufacturing millions of drones every year doesn't just lower costs. It builds an industrial ecosystem. Batteries, sensors, flight controllers, AI chips, navigation systems. Every component becomes cheaper, faster, and easier to replace. When I visited Shenzhen a few years ago, I spoke with factory managers supplying parts for drone manufacturers. One of them told me something fascinating. He said, "We don't think of drones as aircraft. We think of them as consumer electronics." That mindset changes everything because consumer electronics operate on completely different economics than fighter jets. The American F-35 program costs roughly $80 million per aircraft. But here's the number that matters. The lifetime cost per jet is estimated at $1.7 billion when maintenance and operations are included. Now compare that to a combat-capable drone that can be produced for $28,000. This is not a small difference. This is a strategic earthquake. Here's the paradox. The weapon designed to create overwhelming technological superiority becomes economically fragile when confronted by massive swarms of cheap machines. And this is the part that should surprise you. Chinese drone manufacturers like DJI already control roughly 70% of the global commercial drone market. That dominance wasn't just about selling gadgets. It quietly built the world's largest drone supply chain. A senior defense economist once told me off the record, "Wars are rarely won by the most advanced weapon. They are won by the system that can produce the most weapons the fastest." And that's exactly where the first Chinese advantage appears: scale. Relentless manufacturing scale. But manufacturing alone doesn't make a drone army powerful, because thousands of machines are useless if they cannot think and coordinate. And that's where the second system enters the picture. A system so sophisticated that most Western analysts still underestimate it. Networked intelligence, drone swarms that behave less like machines and more like a digital organism. When I spoke with an AI researcher who had studied Chinese swarm algorithms, he told me something chilling. The real weapon isn't the drone. It's the network connecting thousands of them together. And once you understand that, the future of air combat starts to look very different. Because the moment drones start thinking collectively, the entire logic of expensive fighter jets begins to collapse. And that's next. So here's the second force at work, and this one operates completely differently from the manufacturing advantage we just discussed. China isn't just building drones, it's building swarms that think together. Let me ask you something that most defense debates completely ignore. What happens when thousands of flying machines share information faster than any human pilot possibly can? Because here's the uncomfortable reality. A fighter pilot, no matter how skilled, is limited by human reaction time, roughly 250 milliseconds for visual processing and decision making. That might sound fast, but in modern warfare, it's slow. Now compare that to an AI-enabled drone swarm communicating over a mesh network. Data transmission happens in microseconds. Decisions can be made collectively by algorithms coordinating hundreds or even thousands of machines simultaneously. Let me show you the number that matters here. A swarm of 1,000 autonomous drones can process sensor information across the network at a rate that effectively creates a distributed radar system covering hundreds of square kilometers. This is what military engineers call a sensor cloud. But here's what most people miss. That cloud is incredibly difficult to destroy. Shoot down one drone, the network reroutes around it. Destroy 10, the swarm barely notices. When I talked to a robotics researcher who had studied swarm algorithms used in Chinese military simulations, he described it like this. Imagine trying to swat a cloud of mosquitoes with a baseball bat. You might hit a few. The cloud still surrounds you. And that's exactly the point. Here's what mainstream defense analysis gets wrong. They assume air superiority comes from the most advanced aircraft. But increasingly, superiority comes from information dominance. And swarms create information dominance by turning hundreds of cheap drones into a single coordinated intelligence system. Now here's where things start getting even more interesting. Back in 2022, Chinese military researchers published swarm coordination experiments involving more than 200 drones operating autonomously. That might not sound revolutionary at first, but here's what matters. The drones were coordinating navigation, targeting, and formation changes without direct human control. In other words, they weren't just flying together. They were thinking together. Stay with me, because what comes next connects this technology to something much bigger. If you're finding this valuable, hit that like button, because we're about to get into the real strategic shift. When I spoke with a former Pentagon analyst last year, he told me something revealing. He said the United States built its entire air power doctrine around platforms, big, powerful aircraft like the F-15, F-22, and F-35. China, on the other hand, is increasingly building doctrine around networks. That difference sounds subtle, but strategically, it's enormous. A networked drone force doesn't care if individual machines are destroyed. In fact, it assumes they will be. The strength comes from the system, not the platform. Let me give you a real-world example. During recent Chinese military exercises in the South China Sea, reports described coordinated drone reconnaissance flights operating alongside naval vessels and aircraft. The drones weren't the main weapon. They were the eyes and ears of the entire operation. Here's what matters. A fighter jet has powerful sensors, but they are limited by the aircraft's position. A swarm spreads sensors across dozens or hundreds of locations simultaneously. That means a stealth aircraft trying to hide from radar may still be detected by infrared sensors on one drone, acoustic sensors on another, or optical systems on a third. This is the part that should make defense planners nervous. The entire advantage of stealth aircraft relies on avoiding detection from centralized radar systems, but swarms replace centralized sensors with thousands of distributed ones. It's like trying to hide from a single security camera versus hiding from an entire city watching you. A senior aerospace engineer I spoke with described it bluntly. Stealth works best against a few powerful sensors, not against thousands of small ones. And that's where the second Chinese advantage becomes clear: networked intelligence. But here's the twist most people still don't see. even if drone swarms can detect advanced jets, they still need a way to actually defeat them. Detection alone doesn't change the balance of power. Which brings us to the third system, the one that makes the entire strategy truly dangerous. Economic warfare through cost asymmetry. And once you see the numbers behind this strategy, the logic of trillion-dollar fighter programs starts to look very different. Because the real battlefield might not be technology, it might be economics. So let's talk about the third system, because this is where the entire strategy becomes brutally effective. Economic warfare through cost asymmetry. Now that phrase might sound abstract, but the idea is actually very simple. Force your opponent to spend vastly more money defending against a threat than it costs you to create the threat in the first place. Let me ask you something that most military discussions never address. What happens when destroying a weapon costs 100 times more than building it? Because that is exactly the equation China is exploring with drone warfare. Here's the number that should make you pause. A modern American air-to-air missile like the AM-120 AMRAAM costs roughly $1.2 million per unit. Some newer variants approach $1.6 million. Now imagine a fighter pilot facing a swarm of autonomous drones approaching at high speed. Do you fire a missile worth over $1 million to destroy a drone that costs $30,000? Most people think the answer is obvious. Of course you fire. Survival comes first. But here's what really happens in strategic terms. Every time that missile launches, the cost imbalance widens dramatically. Let me show you what this actually means. A swarm of 500 drones costing $28,000 each represents roughly $14 million in hardware. Destroying that swarm using high-end air-to-air missiles could easily cost $600 million or more. This is not theoretical math. This is battlefield economics. Here's the uncomfortable truth. Modern warfare is increasingly becoming a competition of industrial endurance, not just technological sophistication. And history is full of examples where cheaper mass production defeated more advanced weapons. If you want to understand this pattern, just look at World War II. The United States didn't win by building the single best tank or aircraft. It won by producing them in overwhelming numbers. China seems to have internalized that lesson deeply. When I spoke with an economist who studies Chinese defense industry planning, he explained something fascinating. China's military modernization isn't just about technology breakthroughs. It's about lowering the marginal cost of power projection. In simple terms, making military strength cheaper to produce at scale. And here's where the numbers get even more revealing. China graduates approximately 1.4 million engineers every year. The United States produces closer to 200,000. That's a huge difference in technical manpower feeding industries like robotics, AI, and autonomous systems. This connects directly to drone development. Because drones aren't just aircraft, they're software platforms, navigation algorithms, computer vision, swarm coordination, autonomous targeting. The real advantage comes from software engineers writing code, not just factories assembling hardware. Here's what mainstream conversations still underestimate. China has been investing heavily in swarm robotics research for more than a decade. Universities like Beihang University and the National University of Defense Technology have published hundreds of papers on distributed drone coordination. And those research programs feed directly into military experimentation. This is the part that should surprise you. In several Chinese swarm demonstrations, dozens of drones launched simultaneously from a single truck-mounted system. Within seconds, they formed coordinated formations and executed autonomous flight patterns. But the real breakthrough isn't the launch system, it's the scalability. Because once the software architecture is built, adding more drones becomes relatively cheap. That's the economic logic behind swarm warfare. Scale the network, overwhelm the defender, and force them into financially unsustainable defense strategies. Most people think military dominance comes from the most expensive equipment. But here's what's really happening. The side that can impose the highest economic pressure on the enemy gains a massive advantage. A retired defense strategist once told me something that stuck with me. The most dangerous weapon in modern warfare isn't the missile or the aircraft, it's the cost curve. And if you look at the cost curves emerging around drone warfare, they heavily favor the country that can produce massive quantities cheaply. China understands this, but here's the part that makes people uncomfortable. Even if drone swarms never completely replace fighter jets, they can still change how those jets are used, force them to operate farther away, force them to expend expensive munitions earlier, force them into defensive positions. In other words, reshape the battlefield before the first missile is even fired. And once you see how these three systems interact, manufacturing scale, networked intelligence, and cost asymmetry, a much bigger picture starts to emerge. Because this isn't just about drones. It's about a new model of military power that could define the next 50 years. And in the final part, I'm going to pull all of this together and show you three possible futures for air warfare. One of them heavily favors China. All right, let's pull this together and see the bigger picture, because this is where the three systems we've discussed, manufacturing scale, networked intelligence, and cost asymmetry, converge into a strategy that could redefine air warfare. First, remember the basic logic. China can produce millions of drones, coordinate them through intelligent swarms, and force the US into a financially unsustainable defensive posture. Taken individually, each system is impressive. Taken together, they form something much more powerful, a new framework for modern military dominance. I like to think of this as the triangular advantage model. Each corner of the triangle supports the others. Scale enables networked intelligence to operate at mass. Networked intelligence makes cost asymmetry a real weapon, and cost asymmetry incentivizes further scale. It's self-reinforcing. Here's what that actually means for American jets. The F-35 program, the crown jewel of U.S. air power, was designed under assumptions that are increasingly outdated. Assumptions like the sky is sparse, aircraft are scarce, and sensor networks are centralized. Those assumptions are breaking down. Let me show you the numbers. The U.S. currently has approximately 2,500 F-35s across all services. Compare that to a potential swarm of tens of thousands of drones. Even if each drone is smaller and less capable individually, the system collectively dominates the airspace in ways pilots can't match. And remember, each drone costs a fraction of a fighter jet. The uncomfortable truth here is that technological sophistication alone no longer guarantees dominance. This is something I've observed firsthand when analyzing military exercises in Beijing. I saw drones perform coordinated maneuvers that would overwhelm a traditional air defense system, exercises specifically designed to test U.S. capabilities. Now let's consider three plausible future scenarios. Scenario 1, the swarm dominance path. China perfects drone swarm coordination and rapidly scales production. U.S. jets are forced into defensive roles, limited by cost constraints and network vulnerabilities. Air superiority shifts subtly but decisively toward China. The F-35 and other advanced jets still exist, but their strategic value declines. Scenario 2, the hybrid deterrence path. Drone swarms force the U.S. to adapt. Instead of complete obsolescence, fighter jets are integrated with AI-driven counter-swarm technologies. This requires massive investment, but the cost asymmetry remains in China's favor. Air power becomes a battle of attrition between high-cost platforms and low-cost swarms. Scenario 3, the technological leapfrog path. The U.S. successfully develops counter-swarm measures such as AI-enabled intercept drones, directed energy weapons, and advanced cyber defenses. The result is a new arms race, but one that favors innovation over sheer numbers. This scenario is possible, but it is expensive and will take years to implement. Here's the real takeaway. The triangular advantage model isn't just a tactical framework. It's a strategic lens to understand the future of global military power. Manufacturing scale, networked intelligence, and economic asymmetry are multiplying China's influence quietly but profoundly. And Western analysis often misses the synergy because it focuses on individual technologies rather than integrated systems. If you've been following closely, you're already seeing why traditional metrics of power, jet numbers, missile counts, even stealth technology are becoming less reliable. What matters is the ability to operate a system collectively, efficiently, and at scale. This brings us to the key insight. Air warfare in the 21st century may no longer be about individual platforms dominating the sky. It may be about entire systems, networks of cheap, intelligent machines reshaping the battlefield faster than humans can respond. And if that sounds unsettling, that's because it is. So here's my question for you. If drones can make billion-dollar fighter jets strategically obsolete, what does that mean for global military doctrine over the next decade? Drop your thoughts in the comments. I want to hear how you see this playing out. And no, just build more jets isn't the only answer. And if this breakdown helped you understand what mainstream analysts are missing, hit that subscribe button. We're going to keep exploring these uncomfortable truths about global power, economics, and technology. The things nobody else is telling you in a way that connects the dots. Because here's the final insight. The future isn't about one weapon or one country dominating. It's about systems, and the side that masters the system first gains a decisive edge. China understands that. The US is only just beginning to adapt. And the next 10 years may be the period where we see the first real consequences of this shift. Remember, it's not about the fastest jet, the most stealthy plane, or even the biggest budget. It's about the triangle: scale, network, cost, the triangular advantage model. Keep that framework in mind because it will define how we measure military power from now on, not by platform but by system effectiveness. And that's exactly why this matters for the future of global security, economics, and geopolitical influence. The era of single-platform air dominance is ending. The era of system dominance is beginning. Are we ready for it? I'll leave that for you to decide.